Rotating storage is going the way of the dodo. So based on what people predicted over the last 15 years, we shouldn't have hard disk drives today anymore. So why do we still have hard disk drives? I thought about bringing a chainsaw to the stage initially, but someone else did this. So let's go with the toolbox. I'm Rainer from Toshiba. We are manufacturing hard disk drives. And the title is, the hard disk drives are the screws and nails of the cloud and AI world. Our marketing team suggested the pillars or the backbone. I wouldn't dare to say that. Hard disk drives are important, but the pillars and the backbones of the AI world are the GPUs and so on. However, when I thought of AI and hard disk drives, I found some interesting historic correlations that I would like to share with you. So artificial intelligence, as we are talking it today, it requires the algorithms, it requires an enormous compute power with the CPUs and GPUs, and it requires the data storage capacity for the models to learn from. And historically, there have been several approaches to AI which were more or less successful. So in the 60s, at the end of the 60s, people developed the algorithms. So still some of the algorithms we are using today have been developed that long ago. However, the approach in the 60s was not too successful because we were lacking compute power. They were working on transistors, computers that had minimum power. And data storage was more or less not really existing. So we in Toshiba, we entered the storage market in '67, around that time frame. And data storage in these days looked like this. A few kilobytes on disks like this, stacked in machines of the size and the weight of a dishwasher. No way to store the data you need for AI modeling on these things. In the 90s, early 90s, there was another approach. At that time, people did ASICs, application-specific ICs for hardware acceleration, for expert systems, and a kind of AI. It worked better, but it did not become a kind of commercial business because we were still lacking the storage capacity. So, this was the storage in the early 90s. 150 megabyte. This was enough for an IBM PC, for the documents we had, but not enough for any realistic artificial intelligence. So it took basically up to today. So today we have hard disk drives of 24 terabyte for an economic price. People can deploy them in large storage systems. So, but it's not just the hard disk drive, it's also the connectivity and the connection so that storage is widely available everywhere. Like in the 90s, you could connect some of these to one machine, but then it was just around one machine. The current data storage is kind of virtual everywhere. So we have petabytes and petabytes based on our screws and nails. And what comes next? How to not predict the future. Rotating storage is going the way of the dodo. So based on what people predicted over the last 15 years, we shouldn't have hard disk drives today anymore. So why do we still have hard disk drives? It's the cost per capacity. So the hard disk drive is by far the cheapest online storage. Well, there's cheaper storage, which is a tape, but it's not really online. It's the available total capacity. Only hard disk drives can provide the storage capacity of kind of a yearly consumption of an exabyte, 1,000 exabyte, 1 petabyte, 1 zettabyte, exactly. And finally, people think hard disk drives are slow. Yes, they are slower than SSDs. We know this from our laptop computers. But the overall performance is still acceptable for what we want to do with them. And why is this? Some thoughts about general storing technology. So the requirement is it should be cheap. Storage technology is cheap if there is a cheap, scalable media and a single, rather expensive, complex read-write unit. So older storage technologies, like this ferrite type of storages we had in the 60s, or flash technologies we have today, they don't have a cheap media. Yeah? They are like matrix organizations. Cheap media is everything which is magnetic. Then you have a single read-write head that makes it cheap. Storage should keep its data. And magnetic recording is a good way to keep data. So the magnetic recording does not flip back, does not wear out. You can infinitely switch the bits in a hard disk drive. There's no wear-out mechanism. So it keeps the data, and it can be often overwritten. And it should have some agile, random access performance in the compact format. This is better in flash. But actually, the cheapest technology is magnetic, and the fastest within the magnetics is rotating and not tape. And this is how it looks like. So we have, in the year 2024, there was about 1,000 exabytes in hard disk capacity and just 250 in alternative technologies. So let's say 80% of all data that was the storage capacity that was manufactured in last year, manufactured, installed, and obviously filled with data, was hard disk drive. So just 20 in the SSDs. And like cost projections, it has always been that an exabyte or a petabyte or a terabyte of storage capacity is 1/7 of the price of alternative technologies. That's the reason. The cost curves have run in the past and are expected to be run in the future on this logarithmic scale in parallel. And parallel curves meet never. So if hard disk drive industry continues to have higher capacities for the same price, and if flash becomes more dense, and they all have the same price erosion, these curves will never meet. So we will have the hard disk drive as the screws and nails for some more years, for sure. For how long, you may ask? Well, there we should take one step back and think a little bit generally on high volume technical products. For a successful high volume technical product like the hard disk drive, there need to be a demand for it. It only becomes a product if there is a demand. If there's no demand, if you can manufacture something in high volumes and there's no demand, no one would do. for the hard disk drives and for what is currently ongoing and driven and fueled and boosted by this AI world, people want to store ever more data. They did this in the past, data was growing. In the future, we see that there is a even accelerated data growth because everyone wants to store so much more data. Everything people can store will be stored. It will be used for AI model developing, and the more data you can generate, the more data you will store. I mean, on our batches, we have these small chips. This is from a company who want data. They check the data, they store the data. Your movement data around here will fill up our hard disk drives. We can sell more. Thank you for that. Okay, more data. No doubt, AI will boost it even more. The next thing is obviously the technical feasibility. It needs to work physically, technically. If there's a product which has a high demand, where there's a big market, but it does not work, it's physically not possible, there's obviously no product as well. For hard disk drive, this means, from what we see in our labs today, and what the engineers and the research guys are telling me, I would say, in this typical form factor, we may be able to squeeze between 100 and 200 terabyte on that thing. The base physics are there. We just don't know how much it will cost. So it may be way too expensive to be an economic product. If we would sell 100 terabyte hard disk drive today, I mean, there are 100 terabyte SSDs, but they cost several $10,000. If we would be able to manufacture 100 terabyte and sell it for several $10,000, why should someone buy if there is a 24 terabyte for a few $100s? It needs to be economically manufactured for a reasonable cost that you guys are willing to pay, are willing to pay. And for that, we can say, well, 50 terabyte in this, kind of double the capacity from now within the next 5, 6, 7 years, this is possible. That we are working on in our labs, and some of these capacity points are even on the transfer to the production. So we will see those 50 terabyte hard disk drive. 100, 200, we don't know yet. We are working on that. If we achieve, kind of to keep the cost in a reasonable range, we will see them. If not, at some point, this will then be the end of the hard disk drive era. There will be no more new developments, and we will sell them for a few years more, but I hope this is ways after I retire. Current technologies for increasing the capacity, we squeeze in more platter. So we had 9, now we have 10, next we will have 11, and we will use additional energy, microwave energy, laser energy, and we have already shown prototypes of more than 30 terabyte. So this is working, this is reliably working. It's just that we don't sell it because currently it's still a little bit expensive and you wouldn't buy it. You would stay with 24, 22 terabyte today. As soon as we can manufacture it for the price you will buy it for, you will have it. And in our roadmaps, I was asked to show at least one marketing slide. This is the one. But it's also true. It's not just... So after 2026, 7, we will reach the 40 terabyte with some overlapping tracks and 11 platters and so on. Yeah, when will it end? Or when will the epic competition of hard disk drive versus SSD, how this will be solved? Well, I was saying that these price curves, they run in parallel. Well, actually, it was a factor 10. Now it's a factor 7. It may drop to a factor of 5. Well, and it's still 5 times more expensive. And from all we have calculated, from all data we can see, you can see that the SSD, with its high speed, low power consumption, lower footprint area, these components are smaller, they have some advantages over hard disk drives. So the feature advantage that you can better compress or deduplicate data will offset a factor of 1.5. And SSDs, lower rack space, less power consumption, and all these things have a factor of 2. So 2 times 1.5 is 3. So if this ratio of 7:1 have dropped to 3.1, then the approach of having all flash storage to also replace cold storage, to also replace all storage tiers with SSDs may become an option. Yeah? From then it will still take a while until everything is replaced, until so much flash is manufactured to replace everything, but then this may really start. The current approaches of all flash are limited to kind of medium-sized storages, not multiple petabyte scale. No one can afford this today, and there's no reason to do that. And also this point in time will be far in the future. I'm sure it will be after I retire. And finally, we don't see hard disk drives around us anymore, or just some in the NAS systems, in the home NAS, in the enterprise NAS, we still see the hard disk drives. That does not mean the data does not go on hard disk drives. It's the same with the tapes. I still remember when I started career in development, we had these DAT tapes, and we were doing backups every week. These DAT tape drives were on our desks. Somehow they disappeared. This is the last tape I found in the very deep drawer of my desk. Must have been from the 90s. But the fact that we don't use tapes anymore around us, that we don't see these tapes, does not mean that our data is not on tape. I'm sure all of your text declaration, you know this document, the Germans may know these nasty documents on the right. Yeah? All these documents are stored in the cellar of the financial authorities on tape machines. The fact that we don't see it does not mean our data does not go there. The kids are telling me, I have 80,000 movies, pictures of last Taylor Swift concert on my mobile phone. I don't need hard disk drives. No, you don't have 80,000 movies and pictures on your mobile phone. You have thumbnails and you have links. This 80,000 Taylor Swift movies are stored in the data center of your cloud provider, mainly on Toshiba hard disk drives. So thank you, Taylor Swift. More movies, please. Okay. I will skip this because looking 20 years back and 40 years back and 20 years in the future and 40 years back, I already presented last CloudFest. There should be a video somewhere in the internet. I just want to announce that on our booth, which is CO4, at 5:30 today and 5 o'clock tomorrow, we will do a kind of raffle. And what we will do is an interesting thing. We have 60 hard disk drives in one system. Yeah? And out of the 60 hard disk drives, we have 6 RAID 6, so with a double redundancy blocks. And we are passing this to a software-defined storage where we do another RAID 6, so kind of two-dimensional RAID 6. We call it RAID 66. And the experts of you may already guess that from this storage, you can pull a lot of hard disk drives until it crashes. We don't know, and we want you to help us finding out. So we will distribute raffle tickets with numbers. If your number is called, then you can come and pull one of these hard disk drives out of a system. If the storage continues, so it will be under full load, so we will be saving reading, writing data, it will be under full load. If it continues, you will get a small prize. If you are the one pulling the last hard disk drive until it crashes, we will give you hard disk drive. This is together with our partners OpenE for the software-defined storage, AIC for the enclosures, and Microchip for the controllers. So we are looking forward to welcoming you today or tomorrow on our booth and talk more about screws and nails and hard disk drives. Thank you for today.